Hello, welcome again. We are solving GATE 2020 Mechanical Engineering Paper 1. The question number 31 is a rigid massless rod of length L is connected to a disc bracket pulley of mass M and radius R is equal to L by 4 through a frictionless revolute joint. The other end of that rod is attached to wall through a frictionless hinge A spring of stiffness 2K is attached to the rod at its midspan. An inextensible rope passes over half the disc periphery and is securely tied to a spring of stiffness K at point C, as shown in the figure. There is no slip between the rope and pulley. System is in static equilibrium in the configuration shown in the figure, and the rope is always taut. Neglecting the influence of gravity, the natural frequency of the system for the small amplitude vibration, option A root 3 by 2 root k by m, B 3 by root 2 root k by m, C root 3 root k by m, D root k by m. So this is the system. This is rod AB, massless rod, and this is your string. This is spring of stiffness K. This is spring of stiffness 2K. This length is L by 2. Total length is L. This radius is R. Okay. So here we have to find out the natural frequency of this system. Okay. Now let us displace the whole system by an angle theta about 0.8. Okay. Then the displacement of this end, starting from this end, displacement of this end will be, because this is your L and this is your L by 4. Okay. Then displacement will be L by 4 into theta. Okay. So sorry, L plus L by 4 into theta. Okay. This is L up to this L, and then L by 4. Then displacement will be L plus L by 4 into theta. Okay. So this is the displacement of the spring, and the spring force will be your K into displacement of spring. So this will be spring force in upward direction. Okay. And now this mass is moving about this point. Okay. And let I be the moment of inertia of this mass about this point. Then and here the angular displacement is theta. So angular acceleration is theta double dot. So inertia torque will act in this direction. Okay. Because displacement is in this direction. Okay. So we have considered these two. Now the tension in this string will be equal to the spring force, because that is the source of the tension in the string. Okay. So whatever the spring force is there, the same tension will be there. Okay. So the tension in this rope will also be in this direction when we consider this system. Okay. It will exert a upward force on this block, on this system. Okay. Okay. And now if we consider this spring, okay, here the deflection is your L by 2 into theta. Okay. Because this distance is L by 2. Okay. So the spring force and the stiffness is 2K. So spring force will be also in upward direction, and because it is in compression, so force will be in upward direction. So the spring force will be 2L into L by 2 theta. Okay. Now to find out the moment about the frequency, take moment about A. Okay. Moment about A is, so this is your first of all starting from this. Okay. This is the force. Okay. And its distance from this point is L plus L by 4. Okay. So it will be K L plus L by 4 into theta, L plus L by 4. Okay. So this will be this will provide this moment. Okay. L plus L by 4 square into theta into K. Okay. So this is your moment, and next we can say this I theta. I is here. This is mass M. Okay. And it is its center of gravity is this B, and it is at a distance L from this from A. Okay. So its moment of inertia will be M L square. So this will be your ml square. theta double dot. Okay, so ml square theta double dot. Okay, and this will be your, okay, this will be moment of this force. Okay, now consider this. Its distance from this point is L, this distance minus L by 4, or you can say L by 2 plus L by 4. Okay, so and its value is 5 by 4 L K theta, so it will be 5 K 5 L by 4 L by 2 plus L by 4 L by 2 L by 2 plus L by 4. Okay, and next is this force, its moment 2K L by 2 L theta, and its distance is L by 2 theta, so it will be 2K L by 2 into theta. Okay, L by 2. So and it will be equal to 0. Now we can separate the coefficient of theta double dot and theta. So coefficient of theta double dot is ml square, and coefficient of theta is your this quantity. Solving this, we get 48 by 60 naught, or the equation is ml square theta double dot plus ckl square. So frequency is nothing but coefficient of theta divided by coefficient of theta double dot. So answer is root 3k by n. Answer is your C. Okay, next, a strip of thickness 40 mm is to be rolled to a thickness of 20 mm using a 2-high mill having rolls of diameter 200 mm. The coefficient of friction and arc length in mm respectively are, here the strip thickness is 40 mm and rolled thickness is 20 mm. Okay, and so reduction is 40 minus 20, that is 20. Okay, and the maximum reduction that can be achieved by roller is mu square r. Okay, so the coefficient of friction will be r is your this 100 mm. Okay, and so it will be 20 equal to mu square 100, so mu is your 0.45. Okay, so one of the answers can be A or D. Now we will find out the arc length. So this is shows direction of rolling. Okay, and this is the input thickness and this is the final thickness. Okay, this is the initial thickness of the strip, and this is the final thickness of strip. Okay, then sorry, this is the Ti by okay, and so this is your center line. Okay, this is your center line of the strip, and this is your Ti by Ti by 2. Okay, this is your Ti by 2. This is central line of the strip, and this is outside edge, and this is Ti by 2, and this is your Tf by 2. Okay, this is your Tf by 2. Okay, so this is the starting of rolling. Okay, this is Ti by 2, this is Tf by 2, so this will be your Ti by 2 minus Tf by 2, that is 40 minus 40 by 2. Okay, this is R, radius of roll, this is alpha, and so this will be this will also be R. Okay, so this will be your 100 minus 40 minus 20 by 2, that is 90. Okay, so this is your 90, this is your 100. So we can determine this alpha angle. So cos alpha will be your 90 by 100. So alpha is your 25.842, and its in radian will be 0.410 radian. So and arc will be nothing but r into theta. So r into theta is 100 into 0.4510. So arc length will be 45.10. So answer is your option B. Nearest option is B.